wengine naandika, wengine wanaandika zao, wengine wanafuta, they cannot operate. But still, hatuwezi kosa option. We have this option now. We are going to do it this way. We will go through the vectors without, I have a very good document you can go through together. It's the end through, and still you can text me, you can do anything so that we can proceed. Mhm. Uh-huh. So we are going to do it like that, but a challenge tunatafutanga plan B. So hiyo ndio plan B tuko nayo hapo. We will look at very smart notes and zitatusaidia kupata hiyo concept vizuri. Now we are sharing that na share hizo nini. I hope you can see them clearly, eh? Vectors and scalars. That's what I was talking about. Vector is a quantity with both magnitude, length, and direction. If you have somewhere to write on, you can write. You can write that. Examples of vector quantity ni kama gravity. Gravity has direction and it has magnitude. So kuna force. So we have opened the chart. So I want to respond from there. Unaweza chat pale, lakini mkuwe disciplined. And tusaidike. So examples of vector quantities, kuna gravity, kuna force, kuna any other example of a vector quantity, Pale chat, the chat is now open. You can text. You can text. We have gravity, we have velocity, we have force. So when it comes to scalar quantities are those quantities that have got acceleration is also a vector quantity. Very good. Bryson iko sawa. Very, very good, Bryson. Kuna kitu kama kuna scalar quantity, it has magnitude only. An example, we have time. Time has no direction, speed has no direction, mass has no direction, but weight has direction. Okay? So vector is named using the letters at the end of the directed line in a segment like this one. Like here we have vector AB. This AB, we can use a letter like U. You can see the way it is labeled there to represent vectors. So if you are representing vector, there must be an arrow. You cannot represent any vector without an arrow. Momentum, force. Yes, momentum is also a vector quantity. So moving to the way we represent vectors, there must be an arrow to show direction. The magnitude or the size of that arrow is that, like when you compare what you have here, like vector CD and vector FE, we can see both have the direction, but one is bigger than the other one. So one has a bigger size than the other. So by just looking at them, you can be able to determine which vector is bigger than the other one. And also, you can also see the directions they are taking. How do we get the magnitude of a vector? How do we get the magnitude of a vector? Magnitude of a vector. Like, of course, when I represent a vector in form of the coordinates, x, y, x takes the first value, and y takes the second value. So nikiandika kama 2 3 inamaanisha x is 2 and 3 is y. So that represents our vector. Now, if I want to get the magnitude, I get x squared plus y squared square root. We borrow this from Pythagoras theorem of a right angle triangle. Ukiangalia vector from P to Q, you move how many units on the y-axis here? We are considering this. From P to Q, you are moving how many units? To count 1, 2, 3, 4. So you are moving 4 units on the x-axis, and how many units on the y-axis? 1, 2, 3. So itakuwa 4 squared plus 3 squared square root, you get 5. We are borrowing from the Pythagoras theorem. Pythagoras theorem. That's where we are borrowing from. Okay. From there, we have now discussed about the vector, the magnitude of a vector, how we get the magnitude. So if you are given a question and you are told to determine the magnitude of any vector, if there are two, like vector A is, I'm hoping that you're writing. We have a new approach today. We normally do a lot of writing during our lessons, but today we are going to do a lot of talking and displaying the notes, the PowerPoint. If you display PowerPoint, I am hoping that you are busy and you'll be able to follow. Velocity, somebody is talking about velocity as a vector quantity, but I can see anytime anything you text there, I'm able to see. And so please make sure you participate. I was saying, if you're writing somewhere, you can write, you have two vectors, 2 points. 2 points A, which is 3, 4. The other one is 1, 2. 3, 4. A and B is 1, 2. 1, 2. How do you get the magnitude of that vector AB? Because A is 3, 4 and B is 1, 2. The first thing, getting vector AB is B minus A. 3, 4. Unfortunately, you can't write that. You have to write on your side. Ni subtractie uniambie what is B minus A. Itakuwa 3 minus 1, 2. 4 minus 2, 2. Itakuwa 2, 2. So it will be 2, 2. So getting the magnitude or modulus, it is 2 squared plus 2 squared square root. 2 squared is 4 plus 4, 8 squared root of 8. Itakuwa root 8. So anytime you are given the magnitude or the modulus of a vector, two vectors, A and B, the first thing is to subtract B minus A, then nakupatia. It gives you the answer. Kuna vectors and scalars. Calculate the magnitude of the vector, this one. How do you get this? Calculate that magnitude and give me the answer. Chat room. Or you can raise up your to give me the answer. Magnitude. Find the magnitude of this vector PQ, which is negative 4, 3. Take a place. Higher. So equal vectors, vectors qualify to be equal if the components are the same. These components we are looking for, one, there must be, the direction has to be the same, and the size or the magnitude has also to be the same. So in this case, or in our case here, we need to tell me which two vectors here are equal. I'm at 3. Which vectors are equal in these examples we have in here? You can raise up your hand. I'll give you a chance to explain. 220. 220.
Yes, vectors A and G, since they are going in the same direction and the components are the same. G.
A and B.
G.
A, D.
G.
G. Very good.
Yeah.
If it said you're correct.
Since they are going in the same direction and their components are the same.
Very good. Thank you. That's a very good pair. A pair of equal vectors. Kuna somebody else who has not talked today, anaitwa Joseph. 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 Morris. We also have Jonathan.
A and G are equal.
A and G, shaambiwa hiyo. Do you have any other pair of vectors that are equal? What about D and H? They are not equal. Why? D and H are not equal. Since the direction is the same, but the magnitude is different. For D, we have 3 portions, 1, 2, 3. And for H, we have 1, 2, 3, 4. So those two vectors are not the same. Kuna mtu mwingine hapo ameinua mkono. 885. 885. So in short, when you look at those two, yes?
What about E and C?
E and
C.
E and C. Wacha tuone. E and C directions are not the same.
Oh.
You know, for them to qualify to have the same direction, they should be parallel to each other. Is E and C
Like
is E parallel to C?
no.
So tukichora hizo zinaweza kutana, they should not meet. So when you're considering equal vectors, you have to ensure that they have the same magnitude and same direction. Adding vectors. If you add vectors, any two vectors can be added like this. Kama hii, A is 2, 4, and B is 6, 3. When you're adding the vectors, you add them direct. 2 goes to 8, 2 goes to 6, and 4 goes to -3. So X inaenda na X, na Y inaenda na Y. So you can add vectors like that. So in this case, 2, 4, vector A plus vector B should give you 8, 1. That is how we add vectors. In this case, for example, you're given vector AB as 3, 4, and a vector BC as 2, 3. Can somebody give me the vector AB plus BC? Vector AB plus BC. Miguel? Yes. I think country is okay.
The answer is
Oh,
5,
-1.
-1.
Is 5? -1.
-1.
Very good. As we have said, 3 goes to 2 and 4 goes to -5 to get your answer as 4, 5, -1. So when you're adding vectors, you simply, you can't mix X and Y. X goes alone, so X goes to X and Y goes to Y. So I can see there are several others who wanted to try. There are still more questions. Try. If you have vectors U and V, U plus V should be A plus C. If U is AB and V is CD, you add V plus U as A plus C and B plus D to get. That is a general way of adding vectors. Subtraction of vectors happens the same way. X goes to X and Y goes to Y. Eh? Let's talk about zero vector. Victor, your hand is up. I don't know whether you have something to ask. You have a question? So if no question, if there's no question, we can move to zero vector. Zero vector, if you multiply any vector by 0, it gives you a 0. Again, if you add the numbers that get 0, 0 in both cases, you get a 0 vector. For example, if A is 1, 2, and B is negative 1, negative 2, when you add the 2, you get a 0, 0 vector. That's what you call a 0 vector. You can get a 0 vector by adding numbers, but it will give you 0, or you can multiply by a scalar 0. Any number multiplied by 0, it becomes 0. And that's how you come up with a 0 vector. Negative vector, the opposite. Like if I consider my AB as vector A, the opposite of that should be negative. So nikisema AB ni A, alafu then BA should be negative A. If I turn against what I had said, what I had given, I have to put a negative. If you give your AB as vector A, so the opposite of that has to be negative A. So for a vector, like even if you multiply a vector by 0 and by negative, you also get the direction is supposed to change. The opposite of that, the original direction is what gives a negative. So if you add A plus B, you should get a 0 vector. If A plus negative A, if you add A plus negative A, of course you will get a 0 vector. So subtraction, I've said it happens the same way. When you are subtracting, A goes to A, X goes to X, and Y goes to Y. For example, in this case, you're given vector A as 6, 5, and B as 2, 4. Find A minus B. Somebody? Find
4, 1.
Yes? 4, 1. Somebody has said 4, 1. Yes. Naona Machuka. Four one, eh? Many, there are some several hands which are up. 4, 1, eh? Very good. Iko sawa, nimeona. So when you're adding vectors, remember when you're subtracting, you just subtract the vectors, the X part and the Y. You subtract them like that. The answer is 4, 1, eh? So when you're subtracting vectors, we subtract them like this. If U is AB and B is CD, we subtract A minus C, and for Y, D is B minus D. Fine. Multiplication by scalar, you just multiply, opening the brackets with whatever is given. If it's 2, you open with 2. If it's 3, you open with 3, like that. So, like for example, scalar. For example, if Z is 18, if Z is 6, 9, 3Z, you can't multiply the X only and do it. You have to multiply both X and Y. Kama Z, kama ilikuwa 6, 9, and you want to open with a scalar 3, you multiply 3 by 6, then again you must also multiply 3 by 9 to get 18, 27. Sawa? Is it okay? Opening by scalar, like this one, a third of vector 18, 27, it will take you back to. Sawa? So ukifungua, it's just like opening brackets. I may not stay for long there because I know that is a direct, straightforward thing. Unit vectors. For any vectors V, there exists a parallel vector U of magnitude 1 unit. 1 unit. So I want us to consider a unit vector. A unit vector. unit vector is given. It has, okay, units. When we talk about a unit vector, now we are now bringing the issue of component position vectors here. Somebody had asked that question before, and you'll see how it comes in. If one unit, you have two units, like if u is one vector, hapa is a unit vector. U inaingia mara ngapi? Kama ni 3 kwa v, v should be 3u. If one unit is u. So v inafaa kuwa imeingia mara ngapi? Mara 3. So if one unit is u, unit is like that's where now we are going to bring in the issue of I, J, and K, ama I and J. So one unit should be I. So 2 itakuwa 2I. 3 itakuwa I, 3I. For J, if one unit is J, we call it J. 2 units should be 2J. Ndio maana in vectors you'll find yourself with a vector like 3I plus 4J. Because we are taking that I to be our unit. We had talked about the magnitude of that kind of vector. It's here. The modulus. We had talked about modulus. Position vectors. There's somebody in this class who had asked this question at the beginning. Nikamwambia iko hapo mbele, tunakuja kuipatana nayo. Position vector. Like if you consider this A is a position, it's at point 3, 4. Ukiangalia position yake, just as the word suggests, position ya 3. What is the position of vector A or point A from the origin? Position of A from the origin. If you are at the origin and you want to go to A, where do you move? You move on x-axis you move 3 units, and on the y-axis you move 4 units. So it is 3, 4. Okay. So in short, position vector tunauliza from the origin, where do you move to get to that point? Somebody is saying he has not understood unit vectors. Unit vectors hainanga mambo mingi. So it's just we are going to get some examples. Taonyesha pale chini yenye tunatumianga. Umeiona vector I and J. Unakuta umeandikiwa vectors in terms of I and J. Unapata umeambiwa 2y minus 4j. You just bring in those I and J. I to represent the x-axis, the units, 1 unit on the x-axis, and J to represent 1 unit on the y-axis. So if I represent 1 unit on the x-axis and J represents 1 unit on the y-axis, if you're given a vector 4i plus 5j, it means you are moving 4 units on the x-axis and 5 units on the y-axis. It's just for the same thing. It's almost the same as position vector. That's why there's no much that is talked about there. We go direct to position vectors, whereby position vector, you ask yourself, what is the position of that particular point from the origin? A, for you to get to A, you need to move 3 units on the x-axis, then you move 4 units on the x-axis. I'm saying you move 3 units on the x-axis and you move 4 units on the y-axis to arrive at A. So the position vector of A should be 3, 4. The position vector of B, you are moving how many units to get to that position? You move 5 units on the x-axis and 2 units on the y-axis to arrive at B. That is why we give position vector of B or A, of B as 4, 5, 2, 5, 2, 5, 2. From there, if you are told to write down the components of OA, OA is 3, 4, OB is, what about AB? AB, as we said, AB should be B minus A. to get AB, it should be B minus A. So vector AB should be B minus A, and you already have the position vector of A, you have the position vector of B. So it equals 5 minus 3 and 2 minus 4 to get to negative 2. So vector AB should be B minus A. So which is OB minus OA, which is 5, 2 minus 3, 4 to get to negative 2. That is how we get that vector. So in this case, OA is called the position vector of the point A relative to the origin, written as A. Your vector inaitwa A. Sawa? OB is the position vector. OB is called the position vector of the point B, and it's also written as, it is relative to the origin, written as B, like this. We say that AB, if what AB is AO plus OB, like if you're told to get vector AB, in this case, when we find vector AB, given that OA is A and OB is B. Now this, you're supposed to, if you're told to get vector AB, you now move. You want to get vector AB, not the position, not now the modulus or all that. You are told find vector AB. You're moving from A going to B. Sawa? Hiyo sio modulus, unaambiwa utembee utoke kwa A ukienda kwa B. We assume that there is no route between A and B, but the routes given are AO and OB. So you have to move from A to O, then from O to B. So we can say that vector AB is equal to AO plus OB, whereby AO, remember we are moving against what was given as vector A. So itakuwa negative A plus B. So vector AB should be negative A plus to negative. So you can say that vector AB is equal to B minus A. So is equal to B minus A. And vector AB is equal to B minus A. We move. Okay, put after vector AB, but the first thing is to check, am I moving against the direction that was given? If I'm moving against the direction, I have to remember to put a negative. That is why it is giving minus B, minus A plus B. For B, there's no minus because it's moving towards the original direction that was given. Stronger. If P and Q have coordinates 4, 8 and 2, 3, respectively, find the components of PQ. What are the components of PQ? Hiyo nataka kuwapitia kidogo msione. Components of PQ. Is somebody saying that we move a bit slow? We are moving fast. Hands are okay, hands are up. 8, 8, 5. Yes.
It is negative 5, 2.
Yes?
It will be -5, -2.
-5, -2. Huh? That's a good attempt. Mwingine? Joseph? Joseph? Yake imekataa kuongea. At 266. Amejiita hivyo. Makori?
-2, -5.
Very good. Kwa mwisho?
The same.
Dari?
-2, -5.
Very good, very good, very good, very good. Unaona, the components are, ukipatia components of PQ itakuwa Q minus P, which is 2, 3. Components of vector PQ unaanza na Q ya pili ukienda ya kwanza, so it will be Q minus P to get P, which is -4 to get -5. Very good. Umepata correct answers. Thank you for participating and getting correct answers. Position vectors again, graphically they are represented like this. We can have our P, Q minus P. The vectors PQ here, it's Q minus P. So, now, if you are told to go move from P to Q, of course you get to PO plus OQ. PO plus OQ, whereby PO will be moving against the original direction P, and Q will be moving in the correct direction. So itakuwa P minus Q. Iko sawa? That's how it is represented graphically. Points are said to be collinear if what is the meaning of the word collinear? Collinear vectors. Collinear vectors. So if you talk about vectors that are collinear, you are simply saying that those vectors, those points, collinear points, it means that the points are in the same straight line. So hapo unacheza na ratios. Unacheza na ratio. One can be given as a scalar multiple of the other. Now, collinear vectors applies the concept of equal vectors. Equal vectors, for them to be collinear, they have to be parallel. For vectors to be in the same line, they have to be parallel to each other. And one can be given as a scalar multiple of another. So, kama if 3 points are on the same line, let's say you're having like AB. Then there's a third point which is within AB, kama K iko hapo katikati. K can be halfway AB, meaning that AK and KB can be given as half-half. AK is half of AB and KB is another half of AB, meaning that AK is AB, the ratio can be given as 1:1. If there is a way I can represent a vector as a scalar multiple of another, then the two vectors qualify to be collinear. So, like for example, AB is equal to KBC, where K is the scalar, then AB parallel to BC. This can be done in form of an example, collinearity like this one. Prove that A, B, and C are collinear. Can I give you a minute to try that? Prove that points A, B, and C are collinear. AB, you have to get AB, and you also have to get BC. Then we check whether one can be given as a scalar multiple of another. After AB, look for the components of AB and the components of BC first. Tuanze hapo. Look for the components of AB and also the components of BC. Like I can show you how to represent collinearity or how to express that. Huh? I want somebody to give me AB, components of AB. Hakuna mtu ameinua mkono so far. Kwani ni karefu? Ni kitu dogo. Good. Macoris. Uh-huh.
The answer is 6-2.
6-2. For AB,
Yes.
for BC,
4-1.
6-2 and 4-1. So,
Yes.
is there any way that we can express 6-2 and 4-1? 6-2, 4-1.
6-2 and 3-1.
6-2 and 3-1. Iko sawa. 6-2 and 3-1 is correct. So 6-2 and 3-1. So if 3-1 is multiplied by 2, it makes 6-2. Sindio? This means that one can be expressed as a scalar multiple of another. Like 6-2, if you factor out 2 outside, you'll have 3-1 inside. So the ratio of AB is to BC should be 2:1. Since one can be expressed as a scalar multiple of another, it means that the 3 points are within the same line, meaning that they are collinear. One, they are parallel, and because being parallel is one of the qualification of a line being within the same line, of a point being within the same line with other. So what I'm saying is, the question is, are you able to express one as a scalar multiple of another? Can 6-2 be expressed as a scalar multiple of 3-1? Or 3-1, we factor out 2 for 6-2, and we are left with 3-1, which matches the other side. Meaning that AB is to BC can be given as 2:3. So, let's see. You can see, I want to go through the working for a minute. B, meaning that the two vectors are, since AB is equal to B, Okay. So we are moving on well. Nini had appeared kidogo lakini iko sawa. Eh, now I'm sharing same thing we had. Okay, good. We are back there. So we were saying that collinearity, we have talked about collinearity. I think everybody is okay with that. This is a question that you always find in vectors. Napata hiyo swali kila saa. That's fine. We have seen how collinearity goes. That's I don't want to look at the general formula now that everybody has understood. So we want to summarize the whole of this, the general formula. Summarizing, we have if P is the position vector, if P is the position vector of the point P, look here, if P is the position vector of the point P that divides AB in the ratio M is to N, then P is, write this. This is very important. Itakuwa kwa ratio theorem. Then P is M over M plus N A plus N over M plus N B. Here, what happens here? I think I'll explain this again when we do vectors 2. It is my wish that if I get time ahead, I may decide to teach you vectors 2. Vectors 2 is very interesting, and it has so many marks. And it starts from here. So in the ratio theorem, if you want to get position P, dividing line AB in the ratio M is to N, you alternate. So now hii M is to N. N inaenda kwa P, hii ya pili inaenda kwa, okay, inaenda kwa A, na hii ya pili, you not understand if I don't write it down, but you can write it, you can write this first. One, I hope you're writing it. One thing I want you to understand here is if you want the position P, the position vector, or you want the coordinates of P, it is N. So on a point in AB, like if I'm dividing a piece of bread in the ratio M1 is to 2, one person will get 1 over 3, the other one is 2 over 3. So pale chini lazima ikue totals, the ratio. As I've said, kama ratio ilikuwa 2 is to 3, pale chini lazima ikue 5. So one will get 2 out of 5, the other one 3 out of 5. So if you want the position vector of P, or if you want the coordinates of P that divides a line AB into M is to N, chini kwanza tukubaliane. Chini ni A plus M, M plus N. Ni total ya vector. But pale chini ndio tuna change. M goes to B and N goes to A. Zina alternate pale juu. Zina alternate hapo juu. So I wish you can write that first before I explain more. Before I explain more, before I give an example, have you finished? Can I move to the example? This itakusaidia sana hii. This one is highly examined. And it is also applied in vectors too. So kama umemaliza, we can look at an example. Yes. If somebody whose hand is up, kama text. Collinearity, somebody is requesting that we repeat something, and we repeat that part of collinearity. and it was saying that vectors are collinear. If vectors are supposed to be collinear, points, actually talk about points. Points are collinear if they are in the same line. So kama kuna like points start to A, B, and C, how do you prove that they're in the same line? By first getting the position, the components of each. Like, see points in A, B, C. Unatafuta components za A, B, which is B minus A. Then unatafuta components za B, C, which is C minus B. Ukiziweka hapo, you look for a way to factor out. If you successfully manage to factor out a factor which can be a scalar multiple of the other vector, like the way we have done it up there, we have said we had 3, 2, 3, 2, 6, 3. If you have a vector like 6, 6, 2, and 3, 1. 6, 2, ukienda kwa 3, 1, ukimultiply na 2 bado itakupatia 6, 2. It means that 2, 1 can be expressed as a scalar multiple of the other. Ukiona unaweza pata factor moja, factor out. You factor out to get a scalar multiple of the other vector. Then you conclude that the two vectors are in the same line, or in short, they are collinear and they are parallel. Kuja kwa hii, I was giving an example of this. You're told that, andika hii swali once, without even writing the solution first. Everybody to have this question, and it's saying that A and B have coordinates negative 1, 5, and 4, 10 respectively. Okay? Are you writing? A and B have coordinates negative 1, 5, and 4, 10. And $160, kuna kitu anauliza, do you multiply the example will sort you out. This example I'm giving, it's going to sort you out. Hii ukifanya, understand very fast. Is A and B the position vector? Yes, A and B is not the position vectors. The questions you are asking here are sorted in the example here. First, write this example the way it is, so that you can go to the solution. Utakuja ku understand ukifanya hii example. Hii example itakusort vizuri sana. So you're given A and B with coordinates negative 1, 5, and 4, 10, respectively. Find B if AP is to PB is 3:2. If you are done, you can go to the solution. Unaona tumepewa A ni negative 1, 5, B. Here, chini of course chini itakuwa 5 on both sides, lakini juu uta alternate. If it's given, the ratio is given as 3:2, 2 goes to A and 3 goes to B. They are alternating like that. So 2 itaenda kwa A and 3 itaenda kwa B. That is the theorem that you operate with. So P should be 2. Unaona 2 over 5 itaenda kwa A, now 3 itaenda kwa B. In that order. Now, there's somebody who was asking, is A the position vector? Is B the position vector? The coordinates are given there for the position vectors. They are there. So, tulisema it's 2 over 5A. Remember, A was negative 1, 5 plus 3 over 5B. And B was 4, 10. When you're opening the brackets, remember, it will touch both X and Y. So when same as 2 in a multiply, you wanna remember 2 over 5 is just a fraction, it's not a vector. So nisione mtu ana multiply 2 by 1, 2 by -1 ati na 5 chini, hapana. This fraction gets to every coordinate. You deal with each coordinate at a time. Like here you multiply 2/5 times -1, you get -2 over 5. Teremka chini, 2/5 times 5, you cancel to get 2. Hiyo imeisha. We go to the other one, 3/5 of 4 get 12/5. Pale chini itakuwa 3/5 of 10 get 6. We add for x we get 10/5, and for y we get 8. 10/5, of course, 10/5 is 2, and the vector will be 2, 8. Somebody, you are supposed to write that down. Hii itakusaidia sana. This will be tested as it is. It's all. Taipata kwa mtihani. Hii ndio iko tu. Swali itakuwa find the position vector of point P. Unapewa point A kwa mwisho na point B, and there is the ratio, then you're supposed to determine that point which divides the line in those given ratios, or in that given ratio. So write that. You have finished writing that? So vectors in 3 coordinates will be done in vectors 2. We have finished vectors 1. Vectors 1 imeishia hapo. Nakuja Chege, your hand is up.
Sir, I was requesting you to turn off the AI companion.
Yes. You are requesting what?
You to turn off the AI companion so that we have a clear view of the screen.
Oh, it's not very clear.
Yes, because of the companion, of the AI companion. I have seen everything, sir.
It was visible, eh?
Yes.
Okay. Shiroya, your hand is up. At least Shiroya.
Yeah, I have a question about why have you used ratio 2:5 in A, yet in the question A the ratio is actually 3:2.
The ratio is 3:2.
Yes.
Now, if I'm dividing a piece of bread in the ratio 3:2, one person will get 2/5, right?
Mm-hmm.
Another person will get 3/5 of that piece of bread. Good. I want us to start from there. Nitakuelezea tu mpaka ishe. Is it true that if you're dividing a piece of bread in the ratio 3:2, one will get 3/2, the other one will get 2/5? Is it true? Wewe usipotee. Is it true?
Yeah, true.
Then in this theorem, we alternate. For us to get the coordinates of that particular point that is dividing in this ratio, we alternate, we exchange. If the ratio was 3:2, 2 goes to A and 3 goes to B. Ile ya kwanza inaenda kwa the second coordinate. Na ile ya pili inaenda kwa the first coordinate. That is how the theorem says, for you to get the coordinates of that point. So that's why we are saying it is 2/5 of A. Tunaona vizuri, si ati tumeshindwa kuanza na 3/5. It is what theorem says. That theorem says that you should alternate them. Itakuwa 2/5 of A plus 3/5 of B. The 3/5 comes first, so 3 goes to the second coordinate, which is B. Unaona hapa kwa hii line tumechora hapa, kuna AB. 3 is to 2. 3 goes to B and 2 goes to A. Zina alternate hivyo. Na chini ni pale kwa inakuwa totals hivyo chini. Have I explained?
Yes.
Good. Any other question before you conclude, because you're having other lessons? We have, so that you can have a break before you join the other lessons. Any other? If no other question, you can try, of course, you can go to KMF, try to do questions in vectors 1 as you prepare to do vectors 2. Vectors 2 is very important, lazima pia ifanye. So lazima tujipange vizuri. We have taken off well, despite a few challenges we had at the beginning, but at least we have managed to go through the whole topic. Vectors 1 is always in 2 dimensions. Vectors 2 is what is given in 1 dimension. Vectors 3, sorry. Vectors 1 is given in 2 dimensions, and vectors 2, which is done in form 3, is given in 3D. Kuna the third axis, X, Y, Z. Lakini, for us, we only have X and Y. If you inbox me, I can send you this copy. Somebody is asking for a copy of this, whatever you're going through. Trigonometry, unikumbusha next time, That's why at the beginning, I have to give you a chance to suggest what you may want us to go through. So tukianza topic, nawapatia chance kila mtu ajaribu. Today, it was, the request was overwhelming. Everybody wanted to go through vectors, and that's why how we ended up doing vectors. So you can inbox me if you want a copy of that, of this, what you're going through. It's a very good summary of vectors. Summary mzuri, ukiipitia hautakuwa na stress ya vectors tena. So if no other business, we can end our lesson at that point. Have a good day. See you next time.